going to share with you now what are the challenges that we are facing, the industry is facing. Okay. Yeah. Okay. So now I can move ahead. Okay. So today the sharing session will start with a topic or challenges of this BE industry. BE stands for built environment. Now we use the bigger terms, built environment industry. Then number two, will then come up with some solutions. What are the solutions to the challenges? Then number three is the key topics of today's topic will be smart construction. That means the solution will all focus on smart construction. So what are smart construction? There are a few things. So the big roadmap actually is IDD. The BCA, our Building Authority, Construction Authority has actually named it called IDD. It's digitalization. We digitalize all the process. Then we'll discuss what are the technologies involved. In this process of a digitalization and automation. So essentially, there are two parts of technology that we're going to talk about it. How to digitalize it, and then how to make use of technology to go smart. Of course, the last part of the talk will cover a little bit on the advanced construction material (ACM). So this also play a part into our whole smart construction process. So bear with me. One part of technology is digitalization, one part is automation. These are the two key parts, and then plus the number three is the material, advanced construction material. Okay, good. Then we move on. Okay, so the challenges. Look, over here I put it the first challenges, and now COVID-19. So what is it to do with COVID-19 with our construction industry or with our built environment industry? Simply means stop work. So we have been actually asked to stop work for coming to 2 months already. Besides those really essential service, construction service that has to go ahead. Other than that, stop work. So this is a challenge. So think about it. I'm actually posing this question to you also. After we will discuss about the solution. Sorry, excuse me. So think about it, and then we will come to the solution later on. The challenge is number one: COVID-19. Stop work at this moment. Number two, so climate change. Okay, so we are all now facing this big issue, climate change. The water table will rise. In the next 50 years, 150 cm. So where do we go? How do we go? Government also have put in a lot of effort, a lot of emphasis, to settle this issue. A lot of research work. Even a big plan, fund actually are making available to solve this issue. Climate change is not only on this water table rising, also have got issue of this temperature rising. It will affect the living and also human being, also the marine, even the marine animals are affected. This topic will be best shared by our and other friends or the speaker in the series, as I mentioned just now, climate change. Mr. Tan Seng Chuan, about a few years behind me, friends of a CE74, he'll be talking on this topic. Okay, you can join him when we actually got it fixed up the date, and then to deliver this sharing session on climate change. The third challenges, go green. Following up with this climate change issue, so our government or BCA also have putting in a lot of effort. Wanted all the buildings to go green. So this one will be helping the environments in many ways. So go green, we will see what kind of solution that you can actually come up with. We want to have zero energy buildings as far as possible. We actually have divided them, our target, have got the challenges given by the Building Authority. Actually, we are targeting all the building, existing building also, to actually convert them into a low energy building, and then or medium or whatnot. So all effort has been put in to go green. What is the next challenges that we are facing at this moment, or in the future coming, is a living space, short of a living space. So what do we do? Think about it. We'll come to discussion shortly later. Shortage. Then item number 5, challenges number 5, water. So shortage, everybody know, we are relying on our neighboring country for water supply to some extent. We try to now create sources, to actually have self-sufficient supply of the water. So what can we do, or what we have done? So we'll share with you later on shortly. So these are challenges. Then next, workforce. Shortage. Typically, our local people are not so much involved in the brick and mortar laying, construction. So we rely a lot on the foreign workers. So share thousands on work permit holder. Not to mention about other supervisor grade, manager grades, and engineer or whatsoever. Just on work permit holder, we have got 300. Thousands, in the industry. So, what can we do, or what should we do? Government also have come up with some idea, big directions, so we'll share. The next challenges. What do we face? Materials. This is also one of the challenges, on and off. We are facing. We have actually got the times at 2007 when the supply of sand was banned. We have got no material supply. So a lot of the construction in this projects are affected. Cost, supply, timings are all affected. So material supply, aggregate supplies are all in short. We are not allowed to get imported from the countries that used to supply to us. Okay, so these are all the challenges. 7. Number 8. So this is also another big challenges that we are facing. We want zero fertility rate on construction sites, particularly in the construction site. We always tell ourselves, one failure is too many. One fertility is too many. So we try to bring it down where we can. So we have come up with a lot of ideas here and there what to do. Last year, 2019, the numbers worked out to be 1.1 fertility per 100,000. Our target actually at 2020 is 0.8 numbers. So these are challenges. It looks like last year we are moving ahead nearer to our target. Okay, but more can be done. As we said, one fertility is too many. So life is just too precious, to lose it. Okay, so the next challenge is safety and quality. Similarly, we say zero failure. I will share with you over the past years what are the failures that we have got. Okay, so 1979. I guess many of you were not born yet. Our Eunos viaducts came down during construction. Eunos viaducts came down. The next day, I went there. I was on the site next day, and then to see how the the cracks have actually have developed, no, and so on and so forth, no. Yeah. So that just to share with you, things like this happens before. We are still doing very well because we are not doing that. We're not having that many per se. No. Okay. Then the next one. This one is actually so far the biggest failure that we have in our history, where we have claimed 34 lives, 34 people were killed. So I assume that now many of you are still not born yet. The alumni may be around. Some of the alumni that actually had come out and worked for 10 years, they probably were aware this NEWater hotel collapse. Little India, somewhere there were 7-story hotel, and then it collapsed. Then rubbles are seen now. Okay. Next, this also another collapse is a school roof structures during the construction collapse. So 1999. The next one, this is another big one, Nickel Highway. When Nickel Highway collapsed, I was actually sitting in my office. I looked out the window. I witnessed the collapse. I saw fire coming out at the side. My office is just next to Nickel Highway. Happened to be that way. So these are the things that we should try to avoid it where we can. Okay, next, the last picture to share on the failure will be the reason which Changi viaduct collapse, 2017. It's coming to 3 years, 2.5 years. Okay, these are some of the biggest ones that actually we noted, and then we want to share with the younger generations. We should learn from our past experience, and we should try to avoid it. Okay. So as far as quality control is concerned, these are the challenges that now we want to actually make sure there's no collapse, no failure again. One is just too many. Okay. Number 10, productivities. We want to improve the productivities of our construction industry, our built environment industry. We were actually told that now this industry still have a lot of room for improvement in terms of productivities. We are still quite old-fashioned in a way. We'll discuss about the solution later on. Okay. Then come the economy, of course. After all the other challenges we mentioned, now we talk about economy. We also want to bring down the cost if we can. We want to ensure safety, we want to ensure quality, we want to ensure productivity, and so economy. Okay. Okay. Then the last challenges I put it this way. I don't know whether you all can actually pick it up from this this tilted building. Students, can you actually answer or make a guess? Get this guess. What is this building? This slanted building? You have the wind blow from the left to the building. The building slanted. In actual fact, this slanted building, I actually wrote it down. Is a Chinese character. Can you pick it up? It's a Chinese character. If you pick it up correctly, you get 5 marks extra in your exam. Okay. If you look carefully, this building I purposely wrote it in a way that is tilting. It's a Chinese character called not straight. It's one word called standing. Why? 不正 means why. Okay. So it means bad practices. 歪风. The building is tilted. somewhat because of the wind blow. So these current practices, somewhere we must improve it. Now we actually have gotten our other friends to share with us. 1 year my senior, he was the ex president of PE board. He actually told us and shared with us. We have this kind of practice. We don't want to be a CNS engineer. So what is CNS engineer? CNS engineer. He said there are this kind of CNS engineer around, and then we're not doing ourselves a good job. CNS, jokingly, or in the normal way, CNS stands for Civil Structural Engineer. But here we say we don't want to be CNS engineer. CNS stands for chop and sign. If you are the engineer, chop and sign, you're not doing the jobs. So future engineer like you, take note, or even the current practicing engineer, do a good job. Don't be a chop and sign engineer. So this industry, we have got this kind of a practice that we actually should actually remove them or try to get them to switch back. Okay. Besides CNS engineer, then we also have people think that now this kind of idea. People think that now once a piece of work is endorsed or signed by the CNS engineer, and therefore they just push ahead. They do not care whether the thing is actually rightly done or not. So we want to change this mindset. Everybody must make sure under our PE rules. If you do not check and confirm and be sure, satisfy yourself, please do not sign. So we want to actually bring this back to a strict position. Okay, good. So these are the challenges that now we have actually faced in the industry. So now, have you actually thought about the solution now? Right. So now we come. Now we will share with you now a little bit of what we thought we can do to the challenges that we have today. So number one, we look at COVID-19. COVID-19 means what? Means stay home. Means work from home. So I have actually just have a exchange with words with Prof. Tam. Before this talk, yes, we all want to think into further detail how to carry out works at home effectively. So how and what we should do. So now this solution that we're going to share with you will explain why these solutions, smart solutions, are coming about. Okay, so stay home, work from home. It means remote. It means smart constructions. If we can do a remote and auto smart construction, then we solve the problem. Yeah. So in other words, that now we can actually control the construction remotely. There is no contact with the worker among the workers. So isn't it we have solved the problem somewhat? Yeah. So the key word actually, how could we actually conduct our construction as usual remotely? Okay, and then automate the whole process of construction. So these are the big challenge. So mechanizations. These are all keywords lah. Okay. Next slide. Okay. So as I mentioned just now, the key challenges or key solutions here now actually is to use technology. Technology in this particular context has got two parts. One is digitalization. One is automations. So we'll be touching on these two, automation and digitalization. so that we can actually get the construction moved without having close contact among the workers. So fully automation. So I'm posing you a challenge. Yeah, along the way there'll be challenges, posed to you, with the issue that we have. You think about it, young student or future engineers, take challenges positively and then come up with some solutions. So I'm just thinking, I'm actually making challenges to my students or to many people. I also have asked Prof. David Chua in the departments, hey, can we actually come up with a zero worker construction? So this is a challenge. One day, can we see on site, no worker, and the machine will take over. Just right to push our imagination to the maximum, or push the automation process into the maximum. We have zero workers construction. Is that possible? Why not? No, we have driverless cars coming up already, quite matured. So why not driverless construction or workerless construction? Why not? So technologies are there for us to actually take advantage, and then we can move on. So challenges are with you now. Okay. Then climate change. The next topic, solution to climate change. Of course, the detail will be shared with our speaker next round of the talks. So, but essentially, we're going to build. Government actually have come up with funds, to build dikes around the shoreline, so to prevent the water rising issue coming in, to the islands. We don't want to see the whole islands submerged underwater. If we do not take quick action now. So of course low-lying area at this moment, we are trying to build it up. So in some of the projects that we have gone through, we are required, or we are actually advised, at the low-lying area, where to fill up the ground first, build it higher above the flood level. So this kind of approach has been actually with the government policy for some time already. So we take note of this issue long ago. Okay, and then of course the other questions of effective drainage system will be the next topics. How to actually drain away the water effectively. So using mechanical system. Okay, I don't go too far into these topics. I'll leave to my friends to do it next time. Okay, good. So now, the next one, the challenges. Go green. Yeah. So how to go green? We want to have building design, as far as building is concerned, to have zero energy as far as possible, which means make use of the natural energy as far as we can. Recycling material, we've been talking about it for quite a fair bit already. Energy consumption lower, go green, and then we can actually take advantage of the technology. And then on the other hand, BCA are also pushing for timber construction. Our current technology, or our current building materials in the industries are mostly dominated by steel construction or concrete construction. So now we are also say, why not timber construction to go green? Because timber is the type of material that actually have least energy input for the construction. Steel will get the highest. Okay, so think about it. What we can do about it. Go green. Then okay. So this topic of living space, what solution that we can look into it? You know? So of course, one is go tall, go to the sky, go up. So we'll build tall building. We'll build more into the airspace. This is also one topic. Over some study has been done. Can we build blocks of buildings over the rail line? Let's say, for example, MRT station. So the airspace, how could we make use of airspace? So go into the sky, go tall. But of course, in Singapore, we have limited constraint. We have got problems with the height. Just for your information, in Singapore, the general rules, we cannot go tall more than 300 meters. Okay, the building height constraint is 300 meters at the marina area. This simply because we are just a too small island, so the control is by the air traveling. CAS, the what's Singapore? Authority of this CAS, Aviation Authority of Singapore, actually have got control on the maximum height that we can go. So our buildings so far are controlled below 300 meters. So we cannot go too far, too tall. Then the next option will be then go down, go to earth, underground. So we have done a lot of study, to have a living space underground. We study all kind of the impacts. If you are living in underground, social, psychological effects, will be all actually being considered. Then the third choice is go sideways. So we reclaim our land sideways. We also think about building sea structures. Below the water, you have a structures go below the water. Okay, can you imagine? One day you are staying in the structure in the sea. Like the old story, where the sea dragons, the king of sea dragons are staying, the fictions, story or like that. Then last solution, that is also now getting very hot. We are seeing this coming up. Is to have floating structures. So we float the structures on the water. We have got now floating city. We have got floating airport. We have got floating structures for many things. This has got some advantage of it. There is one friend of mine pushing ahead. He's the president of Singapore Floating Solutions Society. Is pushing ahead a lot of this. Okay, good. But anyway, NUS have also got the research project, a big one, to develop, this floating structure system. So this is a big structure, big floating structures potential that now all of you may get involved, to play a part in solving these challenges, in the futures. I think it's Dr. Ang, is taking charge. It used to be CN Wang, Prof. CN Wang before. He has left the school, and then I think Prof. Ang actually is covering or taking over on this piece of research work on floating structures. Okay, so these are the few alternatives that we are looking at. And now then we come to water, shortage of water. So the solution actually we are providing now actually is NEWater. A quick one is NEWater. Okay, and then of course there will be other things. that comes along with it. How could we actually open up to our source of water supply? So there are a few things that we can do. Our PUB have gone into it quite extensively to look at the water supply issue. My classmate will be sharing with you on this called Singapore Water Story. He is a person that actually have gone through all these developments of the NEWater. And then, of course, along the line, in this NEWater development, so this deep tunnel sewerage system is also part of this, the NEWater development system. Okay, he will share water issue, how to overcome water issue. Okay, the next one is actually workforce. I think I'm going to move a bit faster now. Workforce. The answer to solve this problem, of course, where we can, full automation, mechanizations, do without worker, or at the minimum levels. Okay, so this is a concept. So how? So that's why we need you people to come in and then join the force to share, to go full automation. The department has got professors actually looking into this area. You all can actually come in and join them. Okay, and material. Yeah. So as far as material is concerned, so how could we actually come up with some high performance material, high strength but lightweight? So how about recycling material? So how about using waste material? So these are all topics that now we are looking into it. Prof Tam from the department are also working on these topics, the waste material transformations. And then Prof Richard Liu in the department actually have gone ahead and come up with something that's high performance and lightweight. So we are actually going ahead in these directions. What else? Okay, so item number 8, 9, 10, 11, we're talking about safety, we're talking about quality, we're talking about productivity and cost. So this will be the topics that now we'll be going into some detail after these solutions that now we'll complete. Okay, so I mentioned one more time, so to get into your mind clear, our solution to solve all this issue will be IDD, integrated digital delivery. Next one, plus technology. So technology has got two parts. One is digitalization. One is automation. So technology has got two parts. Then the third one will improve our construction industry, smart construction with advanced material. So with these three big topics come together, then we are moving ahead. Construction 4.0. This is a keyword we always say. Industry 4.0 transformation. So applied to construction, we call construction 4.0 transformation. Just for your information, among all the industries, Industry 4.0 transformation, our industry is one of the slowest in terms of transformations. We are still quite old in terms of technology adoptions. So we are quite old. So we want to encourage every one of you to move ahead, to transform the industry as much as we can. We got to catch up. 4.0. So we have got a roadmap for that. We'll share with you later on when we talk about robotic construction. And then, so as I said, the two main part of the technology, one is to look at construction industry 4.0 transformation technology, digitalizations, and automation. Okay, good. So the last challenge Item number 12. Again, make a guess. What is this character? This is a Chinese character. Zhen. To solve the bad practices problem, the slanting wind problem, so we say do right. In short, do right. So to do right, young engineer, future engineers, and alumni, to do right, we need to have two parts. We have to do hard works, hard engineering. So the second one is also hard, but that hard is come together, with your real hearts. You must be sincere, and then be mindful, how to do right. So these are two components, hard and hard. That's how I put it that way, lah. So that will include do right in design, do right in supervision, do right in project management, do right in construction, and do right in maintenance. I want to share with you maybe quickly, just 1 minute, just for you to get a good tips how to do good design, do right design. Okay, I summarize it. Today you are using computer modeling to do right design. So to do right design, I give you 3 steps and 1 principle. I always tell my engineer, tell my interns, 3 steps, 1 principle. What are the 3 steps in your modeling? Whether you are doing computer modeling or your hand calculations modeling. So number 1, you make sure, step number 1, make sure your geometry properties are correctly modeled into your A&D software. Number 2, make sure your boundary conditions are correctly modeled. And number 3, make sure your loadings are correctly input. So you make sure these 3. Then your model, then your software will help you to make analysis and design, come up with a good answer. Okay, so these are 3 steps. Make sure. I have actually seen people coming to me for interview, the PE interview, coming to me with a big report, colorful report. When I question them some on boundary condition, they could not answer. So that is not correct. So how to make sure our boundary condition is correct? Not only assumptions. There's another catch. You must actually make sure. You assume something in your design model, you make sure your drawing productions tally with it. So I also catch people like that. You can assume anything in your assumption. Sometimes it may not be logical. And then your drawing at the end doesn't tally with it. Design assumption. Your models, your boundary condition doesn't tally. And therefore your answer will not be correct. Okay? So 3 steps, 1 principle. What is 1 principle? 1 principle means the sure principle. Everything you do, every step you do, you must have the heart to make sure it's correct. That's what I mean. Be sure. Be sure of every line you do. If you are not sure, please don't continue. Then you will be okay. You have to get advice, check here and there, make sure whatever you do, correct. Then you move on, then you'll be all right. That is the tips that I can give to you. On all these do right, we probably can share with you in another session. Next round, if there's a good chance that we can talk about how to do right in design, supervision, construction, project management. There are many things that now we can improve. Then with a joint effort, I think our construction industry or our built environment industry will be much better. Okay, good. So now we will move on to a slide. Now we're going to move on to the third topic on the smart construction, the technology. Then now I'll show you the slide first. Okay, what people have done. The video. I will show you a video. Some of you may have seen it, some of you may have not seen it, The history rewritten. Okay, yeah, we continue. So yeah, all right. Okay, so now we have seen the video. It's actually a real construction in China. Some of you might have seen it, as I said. This is a 30-story hotel building. It was completed within how many days? 15 days. Huh? So just imagine that now. Of course, this 15 days is a mere assembly time, which means that now they've actually done all the fabrication outside. They just bring here and then 24 hours. They fix it up, assemble. But nonetheless, it only tells you one thing: the perfect planning, the perfect logistics, the perfect arrangement, fit, design efforts. These are all a perfect planning example. So can we do that? Yeah. Some of our people, Singaporeans, have actually gone to stay there. I asked them, okay or not? Now they say, okay, the buildings are okay. But this company, One Tap, has built another 150-story, 1 month, 30 days. They are planning to do a 220-story buildings in 4 months. That is not, unfortunately, that has not been approved. So they are holding up. Anyway, this will just inspire us. What can we do? Going to the fullest of the automations. Can we actually build this as quickly as they can, and then without worker, fully automations? So you will come to our topics of VFMA afterwards. Okay, so now we move on quickly because time is short. I'm going to now go through it quickly with you. So I will go to share with you. Just now I actually started with why smart construction. So now we'll start to share with you where, when, and how. No? Okay, so we move on. I will probably give you some example to go through it. And then challenges. I will also post you some challenges and some initiative that we have it now at the moment. We are doing a lot of research work and improvement work, and then how could we actually bring ourselves forward? As I said, now we are actually one of the slowest industry in transformation, so we want to encourage everyone to join in to move ahead. Okay, IDD, the big pictures. the big direction, IDD has got 4 parts. In the construction industry, we covering the whole life cycle of the construction or this built environment industry. We have first part called design. So we say, can we digitalize design? Yes, digitalize the design. Then we digitalize the fabrications in the factory. Okay, so the third stage, of course, construction on the site. So we also want to digitalize, means actually we enhance productivities. And then the last part also on assets management, on facility management. Can we digitalize it? Yes. The direction, the big direction actually is to digitalize the 4 process: design, fabrication, construction, and then assets management. Okay, so we move on. Yeah. So for good purpose. So this one is just to share with you. This one actually is the 4 area with a good purpose of digitalizations. Okay, then we move on. Okay, so this will be the last topics that we're going to share with you in terms of technology and automations. So the whole things that I'm trying to summarize for you on this digitalization and automation process, the technologies involved. If you count it here, they are altogether about 15. 15 of them. So including starting from BIM until the last one, IoT. So these are all the in thing now, that every one of us should more or less know what is this, and then if we are in it, we should actually use them. BIM, I think the recent graduates might have learned it before. The older one did not, but you can also learn it from outside. In the school, I think Justin, Dr. Justin actually is teaching on this subject matter. So student, pick it up, BIM. This is an in thing now, BIM. It will involve in a very kind of technology for design purpose. Okay, so I will go through it one by one quickly, just to share with you what are they, examples, and then what are the challenges that we can move ahead. Okay, so we are trying to go through it quickly because time is short already. Okay, good. So now BIM. Now we start BIM. BIM actually is building information modeling. We in the old days, architects have come up with architectural drawings in the design. Now we're talking about design. The application is design. Architect come with architectural drawing. Structural engineer have to go and look at it, and then come up with our own structural drawing. And so do a mechanical engineer. Then after that, we have to go and coordinate among ourselves. Sometimes we overload, we crash. The building crash. Design crash here and there. We don't know. So BIM actually is a process allowing us to share the information. So this is called building stand for building information modeling, which every one of us share the same model. A model that come out from the architects in the start will then allow us to put in all our other information, structural information, M&E information, and contractor QS information all into one model. At the end of the day, facility manager, starting from developer, consultants, and then contractor, and then the facility managers, all actually can use this set of drawings, this set of information, building information for many purposes. So this is the whole idea. Of course, at the moment, there are still some hiccup here and there. The platform, there are still some improvement to be done, but never mind. The concept actually is going ahead. We are pushing ahead. BCA is pushing ahead. BIM. So submissions, drawing, design, submission. I will share with you some challenges shortly. Okay, so this is actually BIM to cut short. Okay, so this is a model. Next. Yeah, brand new. Next. Okay, so share with you BIM, the applications. As I said, BIM technology or this intelligence system, the coordination modeling 3D coordination system will be good for 3D application. What is 3D? Is for design. So BIM will be used in the design, architectural, structural, M&E. Of course, in our topics context, we say structural design. How could we use BIM in 3D? 4D is for project management. Project management, maybe before project management, as I said, 3D in the market, BIM software, there are a few, there are about 4. BIM software available. Then our structural design software, there are plenty. The structural design, so A&D, we call A&D software. So how to integrate them together? So this is one challenge. So this one is actually, this is, for example, for design software, you have this Step Pro, you have this Trimble's Tekka software, and so on and so forth. And for BIM software, you have Autodesk Revit, commonly used. Then you have ArchiCAD, and then Bentley and Tekka. So you have all this software available. The question now, how to make them talk to each other. So this is a challenge. At the moment, the talking is not perfect. So you come up with a lot of issues. So 4D, application of the same model, the building model for sharing in project management. So our friend, Professor David Chua in the school has come up with his versions of a software to help in project management. Lean Plan 2 is the name of the software. And then there are also other software around in the market. Okay, many project management software. Then 5D is actually for costing. QS contractor will use this software with BIM models. Then one button, you press one button, you will get all the quantity come out. Quantity of the concrete, steel, reinforcement, so on and so forth. Costing will all come out. Of course, it's not easy to say, but at this moment, there are still issues here and there. But conceptually, we are going that 5D. 6D, 6th dimension, is on energy saving, sustainability checking. 7D, facility management. So this will complete the whole life cycle of a building development, where BIM will be used. You digitalize the whole process. Then the sharing will become effective, easy and simple, theoretically speaking. Next. Okay, so what are the challenges? As I mentioned, okay, currently we are not still perfecting our application. Many engineers, architects come up with a BIM model. May not be complete right in the beginning. So what engineer do? Ideally speaking, the architect model come in, engineers should actually work on the BIM model and then automatically send this information to the design software, A&D software, and got the analysis and design done automatically and come back to BIM software for the answer. But unfortunately, at the moment, it's not like that. At the moment in the industry, you have you are a structural engineer, assuming you are a structural engineer. Architect come up with a BIM model. So what you do, you don't actually develop your structural BIM model immediately. Rather, you actually take advantage of the grid line of the architect models. You build your own A&D 3D model. Your design, structural design, you're using another software. You build another model. Then you come up with answer. Then you pass it back to your drafter to build the structural BIM model. So you actually have gone one round. Okay, so these are the issue. There's another issue. When it comes to bigger project, we need a checker, accredited checker to check it. So accredited checking will have to be done with another software, another design software. So this is also another area that we can look into productivities. So checker will come out. And after they have both done the design check, so how could we know whether the design are correct or not? So the PE does the design and checker does the design, or even submitting to BCA. So all this has to be reviewed. So every stage, every professional has to review correctness, and then they have to look at the answer, look at the thing. It's very time consuming, very unproductive. Just imagine, one set of a calculation may be 1,000 pages. So you have to look for answer, whether it pass or fail. So it becomes a challenge. So now, the model that we are talking about, improvement challenges, is to come up with a overall approach integrated approach where we can actually allow the architect BI model to be understood by all the other engineers BI model. They may be different software. They understand each other. Then this will go on to the design software, also understand each other. Whether AC use one program, PE use another program, all will be combined into one answer, into a BI model finally. And then we're going to present them graphically. So you will see at the end of the day, on the BIM model, the result of PE checking, the PE design, and also the AC design checking. We're going to make it graphically, which means that now you can see if the answer come out in red color means fail. If it's green color, it means pass. Amber color means marginal. So this will help the designer, help the checker, help the government officer, authority officer to look at your design quickly. Because you just need to click the member, you will see the graphical output. That's what we want. So very convenient. Okay. Then we're going one step further. Now, BCA initiative. This is all our government's initiative. BCA. They have got another initiative to come out with a system called model checker. So now, after you have design, structural design by PE, checking by AC, how do you know whether you are doing correct? So now we are going to introduce or come up with a solution. Go through this model checker, software development. Then the software will tell you, yes, you meet all these regulatory requirements. This is particularly on regulatory requirement, not so much on the code check requirement. We have listed down all the regulatory requirement in terms of loading, in terms of a minimum requirement, reinforcement requirement, so on and so forth. So things like this will be built into the model checker software, where it can actually help you to check. And it will actually employ or deploy the technology of AI. Now, we are coming up with a software that actually clever enough, look at your design, be able to tell you, hey, your loadings are not correct. By our requirement, you are not correct. By our requirements, your reinforcement are not correct. By our requirements, we check. AI comes in, look, so we're going to put it in. This boundary condition is not correct because you have this assumption made, doesn't tell you with a drawing, for example. So we want to make our software clever in that sense. Okay, look, these are the directions that we're moving ahead. Quickly, I'm going on to the last one on the initiative of BCA is to come up also a integrated solutions to help QS and contractor. Because at the moment, the BIM software model come out, QS complain. Quantity surveyor, QS stand for quantity surveyor. Builder, contractor complain. They cannot make use of the model and then come out with the quantity correctly. There are some interpretation, some notation issue. Okay, just to let you know, these are also effort. We want to have a smooth flow. Then when the architect model comes in, everybody can use it and then come up with the correct answer. So these are all the efforts now being put in. So this is part of the digitalization process of the design. Okay, then we move on. I think we are running short of time already. So VDC, virtual design. So our concept is to allow with the BIM technology and the VDC technology will allow developer, anyone, architects, contractor, to go through the virtual construction. That means you can actually build the building virtually, and then you can see what are the problems before you do a physical construction, particularly useful for contractor. You can actually build the building first virtually, then understand the problem, then you go on the physical construction. We move quick. So okay, then we move on. These are our process. So the challenges are here. We are saying that now at the moment, we also have actually built up a 3D virtual geotechnical model underground. So the geotechnical property data corrections has been done. So we are this year actually have got the research done by NTU Prof. Chu Jian, and then built a geotechnical model, virtual geotechnical model has been built. In short, in future, if you need any soil data, you can go to this model, and then you can get even virtual wallet for you. Okay, quick one. So these are all the things that now are happening now. Okay, come now, DFMA. So these are big topics. DFMA, in the old day, we do 1D, 2D, 3D precast. And then today, we're talking about PVC. Now we are going one step further. We want to have pre-finished, prefabricated. So old day, 1D, 2D, 3D precast, and then PVC. Then today, our new initiative, we are going to advance DFMA. Just take note. DFMA stands for Design for Manufacturing and then Assembly. Meaning that now you build the building, you prefab the building, components in the factory, bring them to a site, assemble them. So this DFMA, DFMA. So now our last challenges is actually advanced DFMA. I think we're going to move fast now. So this just to show you this 1D, one dimensional. This is 2D. One column beam, and then slab. These are 2D. So these are overview. These are 2D. The slab, hollow core slab. So these are all 2D. These are the plate slab being lifted. Wall. These are 2D construction in the old days. Okay. So yeah, we move on. These are the 3D. 3D. These are viaducts in the bridge construction. So we have a 3D component built, then we join them together. Okay, so next. Okay, this is PVC construction of a private condominium. A box, everything is, you see this one, NTU, is all boxes. So every house units are being cast in the box in the factory and bring to a site, like Lego construction, you join it up. For some of you have not know, so these are information for you. Some of you have learned it, so do it now as you can, as much as you can. So now these are all boxes. We just move on. We'll move fast now. So these are all the component plan that we can do. All precast where we can. Okay, move. Yeah, same. Now 3D, PVC. So this one is a toilet. So now we've been talking about it now. PBU. This is a toilet, prefab toilet. Okay, move. Yeah, same. Okay, so what are the challenges? As I said, the key thing that we are trying to share with you now, to lift up a box, there are a lot of control constraint by LTA on the road. When it comes to the site, just imagine one concrete unit. Guess how heavy is one box? It varies, depending on your design. It can be 25 tons up to 45 tons. Up to 45 tons. So when you want to build a box big, of course, heavy. Then want to lift it up, these are challenge. So now the challenge is, so far, the biggest cranes that we can offer is to build a 40-story building at Clementi. One unit weight is about 45 tons. So these are all challenges. We already got a lot of issue. So therefore, the challenge for us, for you, younger generation, to think about it. How could we actually come up with a big crane system? I think Prof. Paul will be a good person because he's in offshore industry. They used to lift up very heavy structures, in terms of a weight. So this is one area, heavy lifting, that we can think about it. Then the other way around is to cut down the weight of the members, the components, the boxes, using Prof. Richard's answer, high performance concrete, but lightweight. So these are the direction that we can move ahead. So now, beside that, I will move on quick. There are two initiatives that this year have come in. What we have said so far, PVC, is now only being used for residential flats. Now we are going in to talk about in healthcare, hospital, commercial. So this is one area. Bigger span now, heavy loading. The span 12 meter, 7.5 km per meter square loading. Then we are also asking the industry to respond to us. How could we actually handle even larger building? larger span of industry building, of even much heavier loading. So these are all challenges. So I think these two initiatives have not been awarded yet so far. It's a big job. Now I suppose our school, our department also got involved with the contractor. We're going to study this. Okay, so these are challenges. So students, I challenge you, come up with idea if you can, and then share, and then develop. Then we will perfect our PPVC or DFMA construction to the maximum advanced construction methods. Okay, good. So we move on. Okay, so VR, AR, I think these are the things that now we are using it now to see virtually. Okay, wait, let's move on. I think this one, I think a youngster like you are playing with it now every day, so I will just leave it out. VR, AR, virtual reality and augmented reality. Okay, you can see, you can make changes as you like. No, you walk through the building. Okay, good. So on this, I have got one challenge for you. How to use AR, VR technology. I want to build a virtual 3D model of underground services. You know, very often, StarHub M1 fiber cable got cut. Now POB water supply got cut. Very often power's off. No supply. Recently, particularly M1 got into issue. So now what's the problems? How could we avoid it? Most of the time, this all happens because contractor cannot see what are the cables laid underground. They got into trouble. They excavate, they damage it most of the time. So here, I'm proposing a 3D virtual model of all underground services. Can I actually create a virtual 3D underground services model like what we have done for the geotechnical data 3D model? So number one step, I want to create this one. I want to actually then allow the worker to put on the AR glasses. Then you can see when you are doing work on site, you can actually see where are the services below ground, so you will not damage it. Okay, I got one challenge for you. I want to have a sensor to stick on the underground services pipe, so whereby anytime we can actually pick it up from the ground, above ground, with a drone, with a scanner machine, we can actually see a sensor. The challenge that I'm going to pose to you now, can I have a sensor that is maintenance free? I don't want the sensor to be changed. This battery operated. Every 5 years, I have to open up, or 10 years lifespan, I have to re-excavate and then install new sensor. I want to have maintenance-free sensor. So far, I've been looking around for the whole world. No one is giving that to me. But recently, Prof. David Chong was telling me that there may be one solution. So it'd be good that we can actually move in. We're going to set the whole new industry standard. Stick sensor to all the services. Then it will be good for future purpose. So you will know where are the pipes. You would know where are the services you can avoid it. Good. So this one we move on. Okay. This one is robotic construction. So I think simply, you need robots to carry the heavy thing, to do repetitive work, so on and so forth. So this is all robot. Robot today, we also want to address one thing. Robot is no more just robotic arm per se, just be able to carry heavy thing and do repetitive work. We will now want the robot have the sensor built in, can see. We also now want to train a robot with brain. So in short, we want the robot to behave like a worker, can see, can think, can actually respond to circumstances. Okay, so this is a challenge. I think I have no time really. I'm going to move on quick. So robotic construction, we'll just move on. You can see there are many advantages of the robotic construction. You just imagine the whole construction can be done by robots. Then okay, that's it. That is our challenge. Okay. So what is this one? Okay, smart crane. So we actually have built in a smart crane. Come up with smart crane. Prof. David Chong also got a solution, smart crane with sensor built in. So safety consideration. So you don't have the operator to stay in the smart crane, the top, and then you improve safety. Okay. So these are the two examples of smart construction, robotic construction done by Japanese contractor. One is Shimizu. Later on, one is actually Obayashi. So what are they doing? Essentially, they are building. This actually have both of them have done one job in Singapore. One actually in Cecil Street 20 years ago, I think. One actually at I think Housing Board HQ, no, Toa Payoh. Shimizu did Toa Payoh. Obayashi did the one actually along Sandon Way, Cecil Street. So they have a big roof, big canopy, a big roof. A roof will cover the construction from weather. So you have a roof over, therefore you can actually continue to work. Then the transporting system, mechanized, computerized. To lift up the component from the floor up is actually vertically transportation system and horizontally computerization. So automation has been actually done quite some time ago. Japanese are actually the one of the most advanced, in automation in robotic construction. Okay, we move on. Okay, so we have actually got a challenge for that. We want to actually come up recently. BCA wanted to have a roadmap study for the robotic construction. How could we actually move? Where we can move in the next 10 years? Our target actually is to go to meet world-class standard of the robotic construction. So 10 years, now we are going to come up with an idea and then viability to make sure our robotic construction will go ahead. So of course, the key thing that we are fully aware to go robotic construction, the cost is an issue. Therefore, the suggestion actually is to go Uberization, sharing. One party cannot afford to buy the equipment, so we share. So these are the things that now we have in mind. Technology, we must come up with AI, mechanization, or what, sensor IoT comes in. Then cost part we share. That's one part. No, okay. Okay, we move on. Quick, I think we are short of time now. So AI, I think AI and the machine learning. So we just want to train our machine with brain thinking. So we move on. So machine learning has got three parts: supervised learning, unsupervised learning, and then also reinforced learning, which means that now you can actually teach a machine to learn as much as you can, like we are teaching students like you today. We are going for reinforcement learning, that you actually can go through many projects, you learn from there. Besides supervised learning. Supervised learning means that now you are in the lecture hall, we teach you. Unsupervised learning, you can actually learn it outside on your own. Okay, good, we move. I think these are the housing board efforts. Our government housing board actually have done some work with AI to help on safety monitoring system. Okay, good. So what is this one? AI machine learning. So so what our challenge to you actually to have full automation, zero worker. So think about it. Okay, move. Yeah. So big data analytics. So this one in the construction industry, we have so much of the data collection. So how to use technology to analyze them, to predict, to have efficient optimization. So this is a topic. Okay, we move. Next topic. I think I'll just move on. Okay, 3D printing. 3D printing is another new thing that's coming up. But the challenge actually, how to print the concrete structures with the reinforcement. So this is a challenge. So 3D printing for non-structural work so far okay. It's been reported. Our NUS also have got the 3D printing done. So now we move on. 3D printing. So we just move on to you can print building in a short time. Housing board also have done some. Okay. Yeah. So these are effort of the housing board have done some 3D printing. They actually have come up with a grant call, to encourage or to invite researchers who actually do 3D printing. So the challenge at this moment, we move on to the next. So the challenge actually to do 3D printing, theoretically speaking, print concrete no issue, right? Your nozzle, you print concrete. But the challenge actually how to print reinforcement. So now we are going to an idea printing without reinforcement. So Prof. Tan King Hui from the department actually are now moving ahead with fiber study. Fiber add in to replace reinforcement. We have actually done some building of that kind in Singapore, small one, on the ground floor, on the parquet, ground beam. So some kind of a reinforced a fiber has been actually used. No, okay. So this is a challenge. Print the building without steel bar, using fiber. Okay. So this is a challenge. Okay, good. So what next? Also, this one RFID and QR code. So what is different between RFID and QR code? RFID will allow you to track the components movement. QR code only allows you to track where visible. You can see, you use your QR code. If you cannot see, you can't use. QR code will not work, but RFID will work. RFID go on this radio frequency. So even you can't see the component, you are near to it, you can still pick it up if you know where is the component. So the advantage is tracking, quite obvious. So we move on. We move on. Yeah, move on. These are the equipment. Okay. So so drone inspection. So very obvious. Drone will help us to do a lot of work on the facade inspection. So this is coming out a topic also, hot topic. Our facade need to be inspected now from now onwards. BCA actually putting it as a law to do facade inspection. How to climb up 60-story building? So drone will come in. Yes. Okay, I think I have no time already. I just move on. Yeah. So this one actually is a drone inspection I've done at the tallest building in Singapore. I am actually using a drone to look at the biggest signboard, on top of the building. So drone inspection comes in. It helps. Okay. What? Okay. Application drone for inspection. And then for help monitoring of the conditions. Yes, there are projects like that going on. So there are challenges. So So facade inspection, the challenge for facade inspection, the challenge actually for steel facade, we can't see behind. So now I pose a challenge to you. How to inspect the facade from the front and knowing what the condition of the steel boards behind, whether corroded, whether loosening up the boards and then the steel member. So this is a challenge. Okay, good. So this is a robot inspection. So this robot will move up, climb up the wall, and then knock at the wall. You can hear the sound. Okay, so this robot, all has been done. Okay, so these are the BCA efforts, to check the work. Okay, good. We'll move on. I think we have no time. We just move on. Laser scanning. So 3D laser scanning will help us to monitor, to check, to measure crack dimension survey. So breaches and so on and so forth. So this 3D scanner will come up with the measurement immediately, quickly. So we go on the challenge. So this the common problems that in the industry is actually we are very wanted now to have a as-built drawing done. In some of the old buildings, many old buildings have got no drawings, no as-built drawings. So this technology will come in and help to check the building as-built drawing and then give the 2D structural drawings. Next. Okay, smart collaborations. So now working at home, how to do remote consultation, remote inspection, remote supervision. That is a key part. There are a lot of software doing that, but they haven't come to the stage of doing real-time, remote, virtual inspection and virtual supervision and collaboration, and then have it documented, secured, documented. So far, no. So we are coming up. I've done this. I've pushed around this one for some years already, 2-3 years. So now the challenge is that now to push ahead of technology is so difficult, the past few years. But today, in the COVID-19 situation, within 8 weeks, this virtual thing all go ahead. Okay, just to tell you, just to share with you, these are the things that are going on. So these are what we have done. We are going for multiple. My app development for inspection, we can allow multiple meeting together, multiple inspection together, not one. Then we can have security on the documents, on the collaboration documents. Okay, good. We move on. I think we have to move on to the last one. Yeah. So the challenges is to go to the challenge of the smart collaboration is to make sure. I have actually presented the BCA. So we want security. Now we want the supervision video record all in good security conditions. Okay, good. So the last topic will be IoT. IoT is actually making use of sensor no, to do monitoring of the building maintenance, facility management, the disaster management, and then safety management. So all kind of things, energy saving sensor will play a big part. The telco, M1, Singtel, Starhub, they all have got this kind of capability to help you to do IoT. Okay, we are using IoT to do a lot of measurement on the breach behavior. Yes, we move on. To do breach behavior checking. Okay, move on. Yeah. So I think these are all the challenges that we are having IoT. Okay, Internet of Things. Okay, for all kind of a maintenance issue. Okay, right. So we move on. Yeah, I think last one. This is the last topic now. Advanced construction material. We have covered in the front. So now we are coming out with focus on high performance lightweight concrete productions. Waste material, recycling material, soft clay also now can be used. Waste material also can be used, in our construction industry. So now we also have nanotechnology. We use nothing material to actually meet that kind of purpose. So in short, there are many things that we can think about it. So last slide. The challenges. So how to actually make use of the technology or science, like what Prof. Tang have said, to actually transform, convert waste material, recycled material into a good material for use, and then have high performance concrete and steel. So these are all challenges for advanced material that you can think about it. Okay, good.